Okay, here we go with number 17. First question, you have to express these two fractions as a single fraction. So the first stage is to take the bottom of the left fraction, the t minus 3, the bottom of the right fraction, the t plus 1, and create a new denominator. And the way we do that is we just multiply them together. Now you don't have to remove the brackets, you can just leave it like that. So now you've got a new denominator, we need to get a new numerator. So we do 2 times the t plus 1, and then the most important thing here is to remember there's a negative sign in the middle there, so that's going to take away 4 times t minus 3. So if you remove the brackets on the top, tidy it all up, leave the bottom as it is, that'll be it. There is nothing that will cancel, guys, absolutely nothing. Question 2, we've got a function f of x which equals 2x to the power p. Now the first one says x is equal to 3 and p is equal to 2. So if I put those into the formula, f of 3 is going to be 2 times, I'm going to put 3 in for x and I'm going to put 2 in for p. Right, so I just need to work this out. So what's 3 squared, and then what's that times 2? Give me the answer. And you just have to repeat that for questions B and C. Question 3. Now if you were to draw this straight line, you'd end up drawing something which looked like that. Okay, so we're trying to work out what this point here is, what this point here is, and what the gradient is. Okay. Now, looking at this axis here as the y-axis, then this point must be 0 something. So in other words, for the y-axis part of the question, that is when the x number is equal to 0. So all I'm going to do is put that 0 in there. So I'm going to have 3 times 0 plus 4 times y. Take away 24 is equal to 0. So 3 times 0 means this is going to disappear. So I've got 4y is equal to 24, so that gives me y is equal to 6. So this point here is 0, 6. Now all you need to do is repeat that process, but for the x-axis. Now you've got a choice for the gradient. You can either use the gradient formula. Let's shrink that down. You can either use the gradient formula, which is y2 minus y1 over x2 minus x1, because you'll have 2 points. You'll have this point here and this point here. Or you can take the original formula and rewrite it as y equals mx plus c. Your choice. Question 4. Nice, we remove the brackets. So let's say we're going to deal with the first two first of all. So I'm going to do x times x, x times 2, negative 1 times x, negative 1 times 2. That's going to give me another bracket, which I'm then going to multiply the x minus 3 with. So another that times that times that, and so on, all the way across. And then tidy it all up. You should be able to do that. We've done a few of them. Question 5, how do we solve this equation? First thing we need to notice is it's got a squared. So that tells us the way we're going to do it. The way we're going to do it is at some point we're going to factorise equal to 0, and then we're going to use each of these little brackets to get x equals and x equals. However, before we actually get to the factorising stage, so before we get to this stage, we need to get it into what's called the quadratic form. And that is when it is equal to 0. So this 9 is going to have to come over to this side. So bring the 9 over, get an expression up here, factorise it into 2 brackets, solve each bracket. Question 6, name the following 2 curves. Well, we know that the first one goes up to 3 and down to -3. So that's going to tell us y equals what this number is. It looks like a sine graph. And then we just need to work out how many we've got in 360. So if you look at the question, we get told what this number is. So that's going to tell us how many we can get in 360. Second one's a wee bit more complicated. Right, we know that's 0. We know that's -4 down here. So this point is halfway, so that's going to be -2. It looks like a sine graph that would have started up here. And it looks like it's been moved down. So that tells me the formula is going to be y equals a sine graph, and then it's going to be moved down something. Okay, so you need to work out this part here, the amplitude, and you need to work out this part here, how much has been moved down. Question 7. Right, what do we know here? The question tells us that this first angle in here is 60 degrees. It tells us the second angle right round here is 320 degrees. It tells us the first part of the journey is 24 kilometres, and it tells us that the second part of the journey is 30 kilometres. Oops, 30 kilometres. And what we are asked for is this distance here. Okay, so what can we use? Well, we know this side is 24. We know this side is 30. However, we don't know any angles inside the triangle, because this first one goes from the black line to the blue line. We're just looking for this wee one in here. So we don't know that. We don't know this. Stuck. Or are we? Because if I extend this line down here, then what I've now made is a Z angle. So I know that this little angle here is 60. So if I go halfway round, it's going to be 180. Then I've got 60. That means I can actually work out what that part there is. And once I've got that angle inside the triangle, I can use the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Okay, so the secret with this question is finding this angle inside here. Okay, so let me just quickly remind you, this is a Z angle because I've drawn this line in. If this was 60, then I've just moved that 60 round there. I know between north and south you've got to go 180. So 180 to there, add the 60, takes us to this line. And then we know what we need to add to make it up to 320. And that's the angle we're putting in there. Last question, number 8. How are we going to find that white area? Well, that white area to me looks like, if I was doing the question, it looks like I'm going to work out the sector, which is alpha over 360 times pi r squared. Then I'm going to get the triangle part, a half BC sine A. And if I take them away, then that's going to leave me with the wee segment part that I'm actually looking for. Okay, so all we need to do is use this formula, take away this formula, and we get our answer. Now the values that go in these formulas, we know the angle there, we know the angle there, we know the sides there and there, we know the sides there and there. We've got all the information we need. Just put it all in the formula and out it'll pop. That's us.